Hi everyone, thanks for waiting there. So before I get started, there's a few things I
Hi
want
everyone,
to
thanks
heads
for
up.
waiting there. So because
So
of
before I get
the
started, there's
YouTube
a
has
few things I
Hi
want
everyone,
to
thanks
heads
for
up.
waiting there. So because of Okay, so sorry for that feedback. Looks like something goes wrong. Cool. S- So it looks like YouTube has some unknown errors going on. So I'm sorry if if there is some cut off during the webinar. It looks like we have a few more minutes. Let's wait a little bit and we'll get started soon. Hi, good morning everyone. It looks like already 10 a.m. So let's get started with today's webinar. This is Zifan from Singularity Engineering, and I'm the Electronic Application Engineer. So today's webinar is going to be probably around 30 minutes. So I will have some time at the end to answer some questions. Okay, I will first introduce our company. So we are Singularity Engineering. We are located in San Francisco Bay Area. So we support a full portfolio of ANSYS simulation tool. We we have we offer simulation tool from structural mechanics, fluid dynamics to low and high frequency electromagnetics. So let's jump into today's topic, plasma system. So in today there are two typical plasma RF coil configuration. One is the helical coil and the other one is the planar RF coil. So on the left hand side here, we have the helical coil. So with helical coil, we have with helical coil configuration, we usually have the helical coil wrapped around the dielectric chamber, and the plasma is first generated in the region of the coil, then be directed to the wafer. So on the left hand side, you can see how the chamber looks like, and you can see how the magnetic field flow looks like. Magnetic field looks like in this case, and recently there are more and more company interested in the and doing the planar RF coils design because with the planar RF coil design, the biggest advantage is uniformity. So with the planar RF coil, we are able to generate the plasma that is near the plate and across the across the coil entire area that the coil covers. So in this case, um, it makes it makes easier to for the RF coil to for the plasma to hit on the wafer, and with the high uniformity that the RF coil created, we are able to um, we are able to have a bigger chamber and increase the productivity in this case. Sure. So next, I'm going to talk about why simulation is important for RF code design in plasma system. So I have a college friend who used to work at the semiconductor industry, and they are making this type of plasma system. And I was honored to have a tour at their lab in their lab. So I actually see how they design the coils and how they actually test it out. So they are they are pretty new, I would say, a startup. So they are trying to design their own RF coils because today in the market there are many different type of RF coils, as you can see in on the screen right now. So there are many patterns about these plasma RF coils. So they are trying to come out with their own design. So in this case, they have to do a lot of testing because and at the moment they are not using any simulation tool. So what they are doing is they are building the coils, and they are guessing the performance based on the shape of the coils, and um so and then they need to build a prototype. They put it into a giant chamber that's around 3 meter 1.5 meter in radius. Okay, so they actually need to put a coil inside this giant vacuum chamber, and they need to put a lot of wafer in there to test out the uniformity of the coils. So in this case, they are not just doing one single set of coils. They are doing um, four different coils placed in four different place in different position to try to have a uniform field. So in this case, they are do a lot of prototyping, do a lot of experiment. They are saying that one one testing can takes up to 10 20 hours or even just a day or two. So this is very time consuming, and I would say this is very low efficient in the design. So he's asking me for some advice. So that's why I decided to come out with this video. Tell people how important and how significant that simulation can help. So he's he, I I offer him some free trial, which I can offer to anybody who is interested in this topic too. So, and he's actually running he's bringing the entire chamber into the HFSS and have the coil design, the RF coil in HFSS. So he's very happy about it because one simulation from 10-20 hours to a simulation which takes only 1 or 2 hours to complete. So it saves him a lot of time and give him many um, opens up many opportunity to try out different setup and different type of coils. So yeah, so this is why I'm here today. I'm sharing my experience with you. And next, so this is a very typical plasma system that I found online. So we have a so we start on the top. So we have a planar RF coil, which is connecting to the matching circuit, which is um, in real life is a matching box. So the funny thing is, my friend he said when he was testing, it's easy to mess up it. What is easy to mess up is the matching box because something hook up wrong, then the matching box is burned. Then that's a couple $100. So it's actually um yeah, it requires a lot of money and effort. So with the matching box, we connect it to the RF source. Because we want to make sure that we have full power is delivered to the coil. And below the coil, we have the quartz glass that acts like a buffer in this case, and we have the vacuum chamber. So inside vacuum chamber, there's usually a substrate with a plate. So there's on top of the plate, there's many wafers. So we want to make sure the coils have a uniform feel, so that the wafer inside this chamber can all get have a good etching. Okay, so on the right hand side is a very simple model that I created for testing for demonstration purpose. So you can see on the top I have a cover. So here I have a cover which is aluminum. Oh, sorry, jump to the last page. So on the top is the aluminum, and here I have a surrounding which is aluminum too to make sure there's no fuel escape here. So at the bottom, I have a RF, not RF, it's a vacuum chamber. Then I have a coil, RF coil below the RF coil, which is the quartz glass that as you can see here. So okay, next I'm going to jump into HFSS model. So actually here I will start with looking at just the coil itself, and this is something that my friend told me to is um, well he designed just the coil itself, even though it has some pretty good performance, but once he actually put it into an enclosure like a chamber, the performance change. So here I want to show you some show you the difference. So I have the coils simulated in free space. Then next I will have the coil simulated inside the chamber. So let's look at some setup. But on the setup wise, this one and the chamber one will have a exact same setup. Okay. So let's look at here first. We have the RF coil, which is copper. I have two cap. So this is perfect electric conductor. So this tool is for excitation purpose. So I have two port here. These two wave port, and you don't need to worry about the impedance matching in this case because with wave port, if you if you do not normalize it, then the impedance of the wave port will match the impedance of your coil, so you don't have to do any additional matching. So this will save you money from burning your matching boxes. And next we have the air box, which is a vacuum box, I would say. So yeah, so this is a very small setup, and the total, this is below 1 or 10 centimeter diameter, so it's a fairly small design. And the simulation time for this small design is about 3 minutes and 38 seconds, so it's well very fast. And next, I'm going to plot the field. So I create a non-model plate below, just to plot the field. Right click, plot field, so I can plot the magnetic field. So in this case, I can also animate the magnetic field, so you can see whether the field is uniform or not. So I just need to right click, animate. So now we can see the animation. Yeah, so the field is not magnetic field is not quite uniform. But yeah, but here it just I'm trying to show you that the capability that we have, and we can also plot the field for the vertical phase. So for example, like this, I choose a plane, a YZ plane, right click, plot fields, so we can see the field in this case. Same thing, just do a little bit animation. Yes, so maybe I can do the lot scale so you can see it more clear. Oh, guess not, because 0 um, at the outside. But yeah, so yeah, you don't see a very strong field in this case. Okay, so let me see if this works. Sure, this works too. But yeah, anyways, so we don't see a very strong field in this case. But but this is the purpose is just show you that we have the capability to do such simulation. Okay. Oh, maybe I should do this. I should hide this one and just show this one. Okay. That's this. Hmm. Okay. Anyways, so next I'm going to show you the chamber. Probably I should keep the result actually. Yes. I'll delete the second one. Okay. So next we are going to look at the chamber. This is the chamber that you just look at here. We have the aluminum for the lid. So well, yeah, here, and we have the cover aluminum. We have the chamber and RF coil. We have two cap, and we have the quartz glass. So for the material property, these are all included in the ANSYS material library. You can find very standard, most of the standard material inside ANSYS material library. Okay, we have the exact same setup and we have the analysis setup, which is we set up the frequency for this simulation. And for this design, the chamber is not very big. I would say it's for the radius is 7.5 centimeter. Oh, yeah. So you can see this is a very small chamber. Yeah, of course in real life you won't do this, but yeah. Next, the simulation time for this design, let's see, uh, is about 3 minutes. So yeah, so for yeah for fairly large design, you will definitely expect a longer simulation time, especially if you have like something like 1.5 meter in radius. Yeah, that will be going crazy, like very long simulation time. Okay, let's plot the magnetic field in this case. Um, so we can see we have the magnetic field and compare with this one that we have here. Um, Animate. We can see some difference in the magnetic field, right? And we can animate this one too. See, okay, we can see some difference in the magnetic field. Yep. So yeah. So one thing you can do is you can one more thing is you can add the variable capacitor um to your RF coil. So because you have two port setup, so what you need to do is just drag and drop into circuit. So circuit has the 3D model of your RF coil, and you can add like a tuning capacitor to the end, and just a simple setup of the port. Um, is that same setup for the analysis, and you can give it any capacitor value. So run the simulation. After you're done, you just do push excitation. You can then very simply couple the result from circuit back to HFSS. So this will change the coil performance. All right. So I guess yeah. So this is pretty much all for my webinar today. Yeah. So even though this is in my simulation here, it looks simple, but actually going to the real world design, because due to the patterns, people tend to have some crazy idea in the coil design. I've seen rectangular RF coils, triangle triangle RF coils. They put it in, yeah, they put 4 or 5 coils together and try to come up with uniform fields. And um, I I'm I will be surprised if you can do that without the simulation. But yes, I would say simulation in this case will help a lot and save you a lot of time and money. So I believe you want to bring your product to the market as soon as possible too. Okay, so yeah, feel free to ask any question. I can answer some question here, or if you don't ask here and if you're watching the videos, you can always email me for any questions. I will try to get back to you um as soon as possible. So, oh, one more thing to remind you is if you are interested in the plasma system, um, in in November, if you go to our website singularityengineering.com in November, go to media events, then we have another chemical vapor deposition webinar. So this is also for plasma system. And so if you are interested, always feel free to sign up for this one too. So here, let's see if there are any questions. Okay, so it looks like I can wait a few more minutes. If there's no more question, the webinar will end today.
Oh yeah, as I mentioned at the beginning, we are happy to offer free trial if you are interested in this type of simulation. Um, we can also help you set up your model and doing a free proof of concepts and to get you started. So if you are interested in this type of simulation, please reach out. I will try my best to help you. Okay. So it looks like there's no questions. Yeah, the webinar will end here, and hope everyone stay healthy and stay safe. I will talk to you later. Thank you. Bye bye.